All right. Good. So we remembered the variables. So good, Cassette. The independent variable should go on the x-axis and the dependent variable should go on the y-axis. So let me give you some examples here. If we talk about our graph with bacterial growth, we kept track of and measured time. And as we measured time, the result of time going on was bacteria growing. So what we had control over, the measuring of time, is the independent variable that goes on the x-axis. The result of what we control is the dependent variable, and it goes on the y-axis. In a couple weeks, we're going to test out the effect of antibiotics on bacteria. So the different types of substances or antibiotics I use on bacteria would be the independent variables. The result of that, how much bacterial growth there is in the presence of those different antibiotics, would be the dependent variable that goes on the y-axis. All right, so let's look at what we're doing today, and then we're going to talk about Wednesday and Thursday real quick. Today, it looks like we have a lot, but a lot of these actually don't take very long. So you should have about a half hour to get started on. And for a lot of you, even finish your homework assignment today. Now, hopefully by now, as you've heard from other teachers, tomorrow and Thursday this week are asynchronous days. So let me first start by saying Friday is a regular Friday, like it always is. You don't have any class on Friday. You are supposed to use the day to work on homework, studying, catch up on missing assignments, redo assignments, and get help from teachers in whatever way you need to. Wednesday and Thursday are asynchronous because teachers who need their second vaccination are finally getting it. During those days, what you have to do for each class is going to be different and going to be directed from that teacher. You are going to have to do something so that that teacher can record attendance for you. So some teachers might ask you to email them, some might ask you to fill out a Google form, or some might look at your completion of assignments for the day to track your attendance. Similarly, depending on the class and the teacher, some classes are going to assign new work and assignments tomorrow and Thursday that'll be due those days. And some classes, like in here, are going to provide you with time to catch up on work because we're already pretty ahead in our content. We're not behind. So for this class Thursday, your job during this time in the day is not to sleep, it's not to play games, it's any of that. It is to catch up in this class. If you have a 3 or a 4, you're good. If you don't have a 3 or 4, then use that time Thursday to redo assignments that have lower scores and resubmit them. Finish and submit any missing assignments that maybe you forgot about or never got to, okay? And of course, if at any point during that day, you have questions, you run into problems or stuff, then you email me or any of your teachers so that we can help you through whatever content we need to, okay? Does anyone have a question about Wednesday and Thursday this week? All right, I'll take that awkward silence as a no. So we went over the do now. We now want to talk about and look at our bacterial growth graph. We're actually going to do things a little bit out of order of how I have it here. I'm going to ask you in Canvas to click to 3.33. So if you go back to Canvas, we're in modules again, and you want to select the 3.33 page. This is not what it looks like. My internet is just moving at all kinds of awesome dial-up speeds. And when you open the 3.33 page, it should look something like this. So it says bacterial growth graph observations. Now, this graph uses different increments or numbers on the axes than we did, right? On the x-axis, we counted by minutes, 60 minutes at a time. And on the y-axis, we counted, yes, by number of bacteria, but by hundreds of thousands. Regardless of the numbers on the axes, though, your graph from that assignment last week should look like this, right? It starts off a little bit and then kind of skyrockets up out of nowhere. So very simple task here. I want you to look at this graph, click the reply button and post. When you look at this graph, what is a big takeaway you get from this about how bacteria grow? And you're going to click on the reply button. And what is a big takeaway or something that stands out to you about how bacteria grow from looking at this graph? Okay, so I'm going to give you about 3 minutes to do that right now, and then we're going to check back in and move on. Okay, so right now, click the reply button, post your response, and then we'll check in.
Hey, Miss Rosemary,
Hey,
there is no reply button. It is like next and previous.
there's a reply button.
Miss Rosamund,
Yeah.
what's the deal, Brody?
Cassette, you got to make sure you're in the right page. We're on 3.33. I know there's a reply button because last hour was able to do it.
I am the right place. Can I share my screen? Then we can see.
Did you refresh your screen?
Yes.
Okay. Yep, share.
I can refresh it. I see.
That's not the right page.
3 point. Okay. Okay. Thank you. Sorry.
right. So, okay, it looks about half this class has finished it. Who could tell us in the chat, what is something that you notice right away about our bacteria graph and how bacteria grow?
It goes up like every 3 hours.
Okay, it goes up every 3 hours. Yep. What about overall in the graph? What else do we notice about how bacteria grow? Okay, yep, it goes up. So does it go up in a straight line? Okay, so talk to me about how bacteria grow.
Like the graph, it takes a minute to like shoot all the way up.
Okay, there we go, right? So it starts off with just a few bacteria, and for the first set of hours, it seems like the bacteria are barely growing, but then all of a sudden the graph shoots up, right? And so we saw this in our graph as well. Our graph looks something like this, but again, it looked like initially, like there were almost no bacteria, and then before we knew it, it was 50,000, 200,000, and 500,000, right? So it starts growing off slow, and then pretty quickly the population explodes in numbers. All right, so let's go over now your homework assignment from last week, which was 3.30. To review here, there were 3 parts. Part 1 was filling in the data table and calculating bacterial growth. Part 2 was graphing it, and part 3 were kind of like summary questions. So in part 1, we had to fill in the time side, and we noticed that the time increased by increments of 20 minutes. So we had to just keep adding 20. In the number of bacteria side, we had to kind of show or replicate here how the bacteria divide and grow. So we know every time bacteria divide and grow, they split into 2, or the numbers of bacteria double. So in order to figure out these calculations, we had to keep doubling the numbers, which in math means multiply by 2. After 6 hours, we noticed that over 500,000 bacteria had been produced. We started with 1 bacteria. 6 hours later, so a school day basically, 500,000 bacteria, right? And this is always something for us to remind ourselves again that what may have started in any scenario, or Addie's case, of just a few bacteria that entered through her scab, within 6 hours could be 500,000, within half a day was 1,000,000. And then by the time she got to the second hospital, we had millions, multiple millions, right? So we can now really understand how something like that started as something not really serious and kind of exploded into this life or death scenario so quickly. All right, then we had to graph it. And again, we set up our graph like this. And in our graph setup, just like in the graph we just looked at, the line starts off growing slowly and then shoots up, seemingly out of nowhere, right? And it also shows that the population of bacteria grow very, very quickly. So then after that, you were to kind of discuss some of this. Some of these we've already gone over just now. So I'm gonna kind of jump around. Number 1 and 2 and 3, actually 4 and 5, we've gone over. So number 6 says, do you think all living things just continue to grow and grow forever? What do we think about that? Do living things just grow and grow forever?
Yes.
Did you plug it into the Chromebook? Did you plug it into the Chromebook? Well, yeah. I'm sorry, what, Asia?
Oh, I said yes.
So living things grow forever.
I mean, like they grow in it. Well, no, because sometimes they die.
Sometimes they die.
Well,
of us in this class are going to die, but some of us forever.
No, eventually we die.
Okay, all right. There. Whoo, you scared me a little bit there, Asia.
I'll never die.
Okay, all right. We ignored that, Jay. So
I'm gonna live for 1,000 years.
organisms die. What are some things that cause living things to die?
Lack of resources, like things that they need to survive.
Very good. Lack of resources that they need to survive. So food, water, shelter. What else could cause living things to die?
Heartbreak.
It's just too old.
All right, it could be natural causes like age, right? What else? There's something very relevant right now that's going on in the world.
Illness.
Illness, diseases, right? So all of these can affect how living things grow, and that applies to bacteria as well. In our graph, it looks like the quantity of bacteria just increases forever. But the reality is, when bacteria run out of food or water, they will stop reproducing and they will die. If they come across a chemical that could kill them, they will stop reproducing and die, right? And so living things in general don't literally just grow infinitely forever like our graph showed. So where we're moving towards next is understanding what realistically happens to bacteria in our bodies and what happens when we take antibiotics. Okay. We're going to real quickly look at the update here in our evidence tracker. We didn't have very much to update here. Again, this is where we're keeping track of this unit, kind of everything that we are observing and learning. That way, whenever we need to make a model or we have to kind of answer a cumulative thing for the unit, we have all of our information in one place to kind of review and look back over. So this last thing we looked at was our bacterial growth graph. We noticed again that a very small number of bacteria can reproduce to a very large number in a short amount of time, and that graph seemingly kind of just increases and skyrockets very quickly out of nowhere on the graph, okay? And so this helps us to understand how quickly they can grow and also then understand why any type of infection, it could be viral or bacterial, how it can become so serious so quickly, okay? So now if you could click to 3.35 in Canvas. And your page should look like this. Now that we understand how bacteria make more of themselves and why Addie's scenario could have gotten serious so quickly, right? And it's not just Addie's scenario. Any infection can get that serious that quickly because of it. We need to also understand what the different types of bacteria are and what antibiotics actually do to bacteria. So Addie was actually infected by different types of bacteria. What is one type of bacteria Addie was infected by?
Gram-negative.
They were gram-negative bacteria. So, you know, some of us might be wondering, are they gram-positive? What does that difference even mean in bacteria? Who remembers another name they used for a type of bacteria in Addie? It's another name of a type of bacteria that was in Addie. Good, Connor and Kennedy. So steno is the bacteria that got in through the ECMO tubes. Very good. And that was the bacteria that was super duper resistant. What was the first bacteria that infected her and caused the boils to form all over her skin? MRSA. Very good, Connor. So we know she has these different types of bacteria. We know that some are resistant, some are more resistant. So what are these differences? And then we know antibiotics kill bacteria, but how do they kill bacteria? What do they actually do on a cellular level to the bacteria to kill them? Right, so that's what you're going to figure out here in this assignment. So if we could all click on the blue assignment link. And you're going to open up the assignment and it should look like this. And initially it probably looks like, oh my God, this is so long. But again, you can see there's going to be lots of pictures and diagrams. And right, the fonts are big in some places, so it's really not that bad. In the first little section of reading, we're going to read about bacteria, different types of bacteria, some basic structural parts to bacteria, and then you're going to answer 13 questions just about bacteria. Then you're going to do a short reading on antibiotics and different types and actually learn how these different types kill the bacteria. And then you're going to answer another 7 questions just on antibiotics. Okay. These 20 questions then are due by tomorrow night. But 100%, I strongly believe that if you start it right now and focus, you don't get out of this class till almost 45 minutes. I genuinely believe that if you start, focus, and work on this right now, the majority of you, if not all, will finish it before class ends, okay? So again, your job right now is to work on the 3.35 assignment. If at any point you have questions, let me know. Does anyone right now know that they have a question that they want to ask? All right, take the awkward silence as a no. Then you have the remainder of class time to get started on this. Remember, this is due tomorrow night. Remember, you're going to get an email from me about asynchronous Thursday. Keep your eyes peeled for emails from your other teachers for tomorrow. And if your internet is as terrible as mine right now and you need to leave to work on the assignment, I am perfectly fine with that.